Hello everyone, I'm Snigdha Kakkar and this is my channel Accelerate AI Careers. Today I've brought a very interesting problem, Leetcode 94, binary tree Inorder Traversal. It's not a very new question, it's a trivial question. Several people have asked it in the interviews. Some of the companies which have asked this question in last 0 to 3 months are Google, Meta, Microsoft, Bloomberg, Amazon, Apple, Adobe, Uber, Snowflake. So this question is really important. Let's see how we solve this question. So I will be showing this question primarily by two approaches. First, the basic one, which is a recursive solution. And then we'll determine how we can use an iterative approach to solve the same question. So before following any approach, let's understand what does inorder traversal mean through this example. So you have been given this binary tree node here. In binary tree, the input root has been given to you, which is this, and you have to provide inorder traversal of these node values. That's the basic question here. Now, what is inorder traversal? In inorder traversal, you start from the root node, but you do not add that at the moment to your output. First, you take all the values from the left subtree, and in the left subtree also you will check for its left subtree values, and then root, and then right subtree values. So you first finish the left subtree values, but there is no left subtree here. So since there is no left subtree, you will add the root value, which is 1, add it to the output. After that, you will go to the right sub. In right subtree, you will not add the root value directly, which is 2. You will first check its left subtree, which is 3 here. So you will add 3 first. If 3 has any other subtrees, you will check for them first and add the left subtree value there. And then add the root and then right subtree. And subsequently, you will add the root, which is 2 here. So 1, 3, 2 is your output. So inorder traversal basically means you first take the values from left subtree, then you move towards the root, and then you take the values from the right subtree. I hope that is clear to you. Let's look at another example here. So this is the root given to you in example 2. So you first go to the left subtree, and in left subtree also you don't add just the root 2 first. You check its left subtree, which is 4. So first 4 gets added, then root 2 gets added. Then you move towards the right subtree, which is 5, 6, 7. But you first add the left subtree values, which is 6, and then root 5, and then right subtree 7. After finishing all this up, you go up towards the root, which is 1, and then move towards right subtree. In right subtree also, you first check if there is any left node value with root 3. There is no left node, so you add the root 3. And then you move towards the right subtree of 3, which is 9, 8. Since 9 is the left node, so it gets added first and then the root 8 gets added. So that's how your output is obtained. I hope that's clear to you what's inorder traversal. For example 3, you have the input root as blank, so your output will also be blank. For example 4, your input root is 1, your output is also 1. Now let's understand how will we solve this recursion. So as we walked through the root, if you do it in recursive fashion, you basically will be using recursive stack to save these root values while you populate all the left stack values, and then you pop each root value out and then add it to your output. That's the basic approach you're gonna do. And recursion is an easier way to solve this question. Now time complexity in recursion would be O of n, since you have to check each node and go through all the node values in the root. So that's why the time complexity is O of n. The space complexity in worst case scenario would also be O of n, because you are using recursive stack and it might have to store all the node values in certain scenarios. So the worst case scenario would be O of n time complexity and O of n space complexity. Now let's code recursion and then we will move towards the iterative approach. So to code recursion, I will first initialize the result variable, and then I will write the nested inorder function, which I'm going to call for any recursion, and I'm going to pass root. First, my base case, which is if there is no root, if the root value is null. In such a scenario, just return empty, nothing needs to be returned. But if there is a root, in such a scenario, for inorder, you first process root.left. After that, you add the root. So result.append root.val. So you have already processed the left subnode. After that, you add the root.val, and then finally you process the right subnode. So this is the recursive call you are making to left and right subnodes in between this function, and that's it. There's nothing else to be added to this function. Now you just call the function over the root, and once you have called this function, it will recursively process each value in the entire root, And finally, you can return the result. Since result will have all the values updated saved to it. I can run this solution and we can see how it works. It's accepted. Let's submit. So it beats 100% of the solutions here. So recursive approach is also good. Now let's see how we can solve this question iteratively. Now for iterative solution, I have taken an example of my own here. 1 is the root. It has 2 children, 2 and 5, and then 2 has 2 children, 3 and 4. So this is my tree which I have, binary tree. And now I have initialized my result empty list here, and this is my stack which I'm going to use for the iterative solution to demo here. So in iterative solution for Inorder Traversal, we are going to replicate exactly what we did for recursion. But in recursion, we basically used an inbuilt recursive stack, right? But here in iteration, we'll just replicate the same thing by using an external stack. So when we use external stack data structure, let me demo it using this example here. So for starting from one parent node, we'll not just add it to the result. We will keep on going to its left child nodes like 1 to 2, then 2 to 3, and then 3 to 9. As soon as we reach end, while going to the left, that is when, so we first add 1 to the stack, then we add 2 to the stack, then we add 3 to the stack, and then we have null. As soon as we reach null, we pop the parent node out, the first node out, which is 3. So we pop it out and we add 3 here. Now after that, we go to the right. After adding the parent node 3, we go to its right. Now the child node, right child node of 3 is also null. So nothing gets added to the stack. Then we again pop, since there was nothing to the right of 3, right child of 3. So we pop again from the stack, which is 2, and we add it to our result. And we pop it from here. After that, we check for right child node of 2. So right child node of 2 is 4. And again, same ways, we'll do iteratively. We'll check for left child node of 4 until we reach none. And then we pop 4 out. So we first add 4 here. Then we check for left child node of 4. There is no left child for 4. So we pop 4 out, add it to the result. Then we check for right child of 4. There is no right child. So we move ahead and we pop the last value from stack out, which is 1, add it to the result here. And then we check for right child for 1. Right child for 1 is 5. We add to the stack. We check for left child for 5. There is no left child for 5. So we pop 5 out, add it to the result. Then we check for right child for 5. There is no right child for 5. So finally, we have exhausted all the values in the stack. Our stack has become none, and our current pointer has also pointed to the none. So we have basically gone through the entire root node, and we have also emptied the stack. That is the time we have to stop. So I hope you understand from this explanation what we are doing. We first run a while loop for the left child. Until we have the left child, we keep on adding to the stack. As soon as we reach that none value in the left child, that is the time we pop the last top of stack value out and add it to the result. After that, we check for the right child. And then subsequently, we repeat the steps of checking for the left children first. Then once we reach none, then we pop the top of stack value, add it to the result, and then we check for right child. So that's how Inorder Traversal will work. Now I have demoed it to you using an example here. Let's start coding it. That will explain it better. First of all, I initialize my result list and I initialize my stack. After that, I also initialize my current pointer with root, and then I'll write my while loop. So when should I stop? When my current node is pointing to none or my stack is empty. Either of the two is true. If my current node is not none, or if my stack has some values, you have to go on. So that's what I'm doing. Now I'll also check while current node is not none. You will keep on going to the stack. So you will keep on appending the values to the stack. After that, you will keep on going to the left. Move the current pointer to cur.left. Now you will go to the left until your current node has become none. And then you have to pop the value out. So that's what I'm doing, stack.pop. Then this value I'll store in my current pointer. This value I need to append to my result. So result.append current dot. That's what I have done. And then I will check for right, whether there's a right child or not. If there is a right child, then again the same process gets repeated. It will keep on appending it to the stack, then it will check for its left children, then it will pop the value out once it has reached none in left children, and then it will append it to result and check for right children. So that's what the process needs to repeat, and finally your result will have the entire Inorder Traversal values, and then you can return your result. So even though the code looks a lot different from the recursion code, because in recursion code you didn't use any while functions but you used a recursive call to a nested function. Here we are not doing that. Here we are using the while loop and we are using our stack. So since we are using stack, and that stack might have in worst case scenario all of the elements in your root, that can be in case when you have all children in the left direction and you keep on adding them to the stack before you pop anything out. So that's why your space complexity would be O of n in worst case scenario, and your time complexity would also be O of n since you have been traversing through the entire route. So let's run this. I made a silly mistake. I typed current twice. Let's run this. Let's submit. As you can see, it beats 100% solutions here. Even though this solution seems very simple on the outside when I wrote it for you, but writing this code for the first time when you are doing Inorder Traversal using iterative fashion is very difficult. So even though it seems easy, it's not easy. So this question has been tagged wrongly as an easy level solution if you are coding it for the first time using iterative approach. So I would suggest you pause this video, try coding it yourself. Let me know if you have any doubts in the comments here. I'll be happy to help you out there. If you like my way of solving problems, subscribe to my channel to get your notifications for your daily LeetCode challenge. Thank you.